Hi folks, minor change of plans. I originally wanted to do 3 episodes on the different platforms I want to use for the microcontroller tutorial series, but I just decided it might actually be better to give you a quick overview of what options there are so you can do some shopping, maybe, and basically give you a somewhat comprehensive overview what I'm using and what you might want to use. So got plenty of stuff there on the bench. Well, I think just gonna grab the camera and we gonna take a look. Hang on. Okay folks, candidate number 1, MSP430 Launchpad, or exact name, I hope you can read that, MSP EXP430G2. Okay, you can see this box has already traveled a bit with me. There's some documentation. There's the actual board. I see it's nothing very big, nothing very fancy actually, but it's actually quite nice. Here's the USB connector we use for programming and powering the device. This is the programmer section. And there's a bunch of jumpers that connect the programmer part to the target board part, where we have a microcontroller. It's socketed, so we can replace it with others. The headers are introduced, the pins of the microcontroller are supported on these external pins, one on one. There's a bit of power, a reset button, 1 input button, and 2 LEDs we can actually use, well, basically to make them blink or whatever. So that's the actual board. Looks quite a bit like an Arduino, but it is different. There is no abstraction layer like with the Arduino, so we can use different microcontrollers here and Arduino takes care of the rest. We actually have to deal with the individual microcontrollers because we get full direct access to them, which is cool, but decidedly different than what we normally do with an Arduino. So what else do we have in there? There's USB cable, always handy because you can be sure it'll actually match on the device side and not be just exactly the wrong one. We have a second microcontroller. What is that for? Well, in case you fry the first one. Now, well, might as well, but this is a different one. So you can actually try with different microcontrollers and see how you get your things to work on different targets. Then there is, I haven't even bothered to unpack this, but this is actually, let's see if I can get this closer. This is a clock quartz. So on the board, there you can solder in another quartz, and this one clocks the entire thing down to 32.768 kilohertz, not megahertz, which basically means that well, you can use this thing at very low speed. And why would anybody do that? Because power consumption grows by the square of the clock speed. So if you're really into saving power, and the MSP430s have a reputation to lose in that area, because they, if you know what you're doing, it can make them really power efficient, and clocking the thing down is one of the key steps in doing so. And then there's something that is really cute. Now, there is a YouTube video by an engineer from Texas Instrument, and she explains that a lot of people originally complained about these being male headers rather than female headers like on the Arduino. And so they decided we add female headers along with the boards, and you can replace them if you want, have to desolder the existing ones. And yeah, I personally think it's kind of, well, stupid is a bad word for this, but it doesn't matter if you use male header or female headers. They both have advantages and disadvantages. and you can't always please everyone. So adding this, I'd say it shows a tremendous amount of goodwill, which is always a good sign, but it wouldn't really have been necessary. And by the way, let me pack all this back again. I just, for the fun of it, got myself a second one, and just recently. And with this one, they actually soldered the female headers to the underside of the board off factory. So that's actually kind of nice. It's strange, they still have these little rubber feet on there, so you can't you can stand it on the bench without risking a short, despite the fact that they now have these headers in here. Well, yeah, that's what they have. These boards, they are pretty much a no-brainer. You can get them for something like, well, I've seen them for $10 US on the TI webpage, but shipping and handling from the US actually makes it more reasonable to spend like 12 or 13 euros for one of these here. I've also seen them for about 30, so you want to be careful a bit where you buy them. But for that amount of money, if you're really on a tight budget, this is pretty much your only option anyway, unless you actually can get some other stuff for free or already have it lying around. And if you don't have to worry about money that much, well, just buy it and leave it sitting on your bench until you actually find time and reason to play around with them. So that's the TI MSP430 stuff. Next, and this is going to get strange. This doesn't look like anything much, but it's actually an STK 500, which is an Atmel board. The first one I actually started with. It's a huge big bastard, and it sets you back about something like almost 100 euros. And it has USB serial interface, so you also need a USB to serial adapter, not included, and you need a power supply, so the whole thing altogether costs you about 110, 120 euros. Again, we have a programmer section. We have a microcontroller part of the target side, and we have a couple peripherals. And you can use, and there were actually more of these with them originally, you use these ribbon cables to connect things to different places. There are a bunch of different sockets for different microcontrollers, so if you want to try another one than the one originally included, you will first want to figure out where to put it in, because you don't want to put a device into the wrong socket. We have 2 of each size, and they're for different targets. It got me started for some pretty penny, but I'd strongly recommend not to spend money on this. Why? It's expensive, decidedly expensive by today's standards. It's unwieldy. If you want to use it just as a programmer, have a big thing like this sitting on your bench, it's not really exciting. And using a serial interface, no. So the only reason why you might want to use this is because somebody gives you one, says, I don't need it anymore, just have it and have fun with it. I've learned things with it that way. So yeah, that might be reason for it, but otherwise don't bother. Now, once I got this and figured out that this is not really the smartest thing, I got myself this as my controller. You get things like this from all sorts of manufacturers. I paid about 22 euros for this, I think. You get similar ones for down to 15 euros. Most of them then not with a plastic case. I personally recommend go for one of these, but with a plastic case included. It just makes it much more convenient. You just drop it in your bag and take it with you, and don't worry about it. If you want to play around with Atmel microcontrollers, this actually makes quite a bit of sense. It's about as cheap as it gets with Atmel. And as I said, 15 euros, not a big deal. Only thing is you also need a target board because this is just a programmer. So we have to take a look at target boards as well in a moment. Leave it there. Alternative to that is something kind of strange. This is a bus pirate. You can buy the bare PCB. You can get these laser cut things instead of a proper case separately. And you can get various cables and things. So I've ordered, and all you have to order these things all separately. So this is an adapter, goes into the box header here, 10 one of these test hooks. You can also, and that's what makes it interesting for a number of things, get a cable like this which has individual male headers, male pins, which are actually even labeled, which I find really a nice touch. What you can't buy is a cable that just turns this into, or that works as an adapter, so you get standard 6-pin AVR ISP connector from the 10-pin connector here. But it's a bit of an odd, by the way, yeah, let's start with this. It's a bit of an oddball because this isn't meant as a programmer. This is basically a device, USB to just about anything you can talk with various chips, like SPI, I2C. I think it does use UART serial, but I haven't actually checked that yet. And because the ISP programming interface Atmel is using is basically a variant of SPI, you can also use this as a programmer. Actually works, I've tried it. It also allows you to talk directly to various other devices. And there's even, and you have to buy that extra again, this which is an interface to some LCD displays. And I ordered this from China, so I ordered some stuff there anyway. Decided might as well give it a try. And I haven't used it very much yet, but I guess this will show up every once in a while in the series because it lets you talk to devices without first programming a microcontroller. So that's cool. And then I have, this doesn't really belong here, but I keep it in there anyway. This is an AVR Dragon. First off, this is the only official AVR programmer thing I have. Sets you back about 75 euros or so. Why did I buy it? It again talks USB. It talks ISP like the other ones. It also talks JTAG, which is both programming and debugging interface, which I guess will be useful at some point in time. We should actually take a look at the debugging features of both the MSP430 and the Atmel series. I don't even know if the PIC stuff has features like that. So what's missing here? You can add headers here for high voltage programming. Sounds scary, but basically means you use 12 or 15 volts or so to indicate to the device that you actually want to program it. And then you could actually, in theory at least, cut it off here. And what you can then do, you can put an additional 2-row header in here, which then connects one-on-one to an IC socket you can put in here. And if you really want to spend some money, I mean these are about 15 to 20 euros, you can actually put one of these, let's see if I can get that in here with the glasses on, zero insertion 4 sockets here. And what you do is you use jumper wires to connect the correct pins from the programming headers to the pins on the socket, which are basically connected to these extra rows. The reason why Atmel didn't just finish this thing, I don't know about the headers here, but these things are 15 to 20 euros, as I said, and they make these things significantly more expensive. And Atmel really tried to provide full-blown, full capability programming device that actually was affordable to the enthusiast, which is nice again. And yes, you have these cables. So there's the 10-pin header for JTAG, 6-pin for ISP, and one of these days I'm probably going to take what's that, 5, 9, probably 20-pin header or so that fits on both at the same time, and use that to bring both ends out at the same time. Because what a lot of people apparently do, because this doesn't come with the package, they just keep it in here, cut a little hole in here for the USB interface, and just connect whichever programming interface they need, and just keep that thing sitting on the bench. Simple, kind of primitive, but it actually gets the job done, which is the only thing that really counts. I expect we're going to see a bit more of this when we take a look at the JTAG capabilities of the Atmel stuff. Now, that's number 4 of the ones I'm going to these are the 3 ones I'm likely going to use. There's one more option, which is, yes, an Arduino. Because with the standard Arduino development environment distribution, there's actually a sketch that lets you use an Arduino as a programmer. Bit awkward because you have to use jumper wires to your target, but it actually seems to work. And an Arduino Uno clone sets you back about 15 euros. So that might be, well, it's about the same price class as this, so it doesn't really make much of a difference. But if you have an Uno lying around that's unused, that might actually be worth a try. I'm not going to bother because using the jumper wires is just a pain in the ass. Now, with all of these, we don't have a target board yet. Question is, what could we use as a target board? And what I have for that job is another Arduino. Because remember in the previous episode when I explained that Arduino is kind of like Java in the regular computing world, it doesn't let you talk directly to the microcontroller, right? Now, Java has what's called the Java native interface, a real pain in the ass interface to use if you actually have to talk to the operating system. And this is the Arduino equivalent of the JNI. This is a 6-pin programming header. And with that, you can program the microcontroller directly without going through all the Arduino stuff. And for that reason, I'm going to use this as my target board. Not as a programmer, but as a target board. Alternative, which I already have here, could be something like this. 80Tiny 13 or 25 or whatever I put in there. They behave pretty much all the same anyway. Decoupling capacitor, pull-up resistor on the reset pin, an LED plus series resistor to make blink, and this is just an optional thing to indicate that the thing actually has power. If you're really tight on a budget, you might actually go with this, but I'm only going to touch on this once we've got the toolchain up and running. We'll get back to this in a moment, or in a near future episode. So much about Atmel AVR, and the only thing that's left to talk about is PIC. Let's get rid of this, and what I have for that is this. It's a PIC 2 Debug Express. I've had it sitting here for quite a while, and there's a programmer, PIC 2. In a way, quite interesting thing. It has one feature that unfortunately you can't use with the open source tools. But if you use the official provided software, which actually somewhere in here as well, I'm not going to bother, you can store whatever program you want to upload to your microcontrollers on here disconnect it from the computer, connect to the target, press the red button, and it'll actually upload your code to the target, provided you still have power. So you might actually want to use a power bank to power it, but might be convenient in a number of situations. This is the target board provided, and this is a pretty much complete disaster. First off, you connect them like this, which is basically just a matter of time until you start bending the pins. So no, this is not official microchip gear. This is just my response to that, having a little adapter cable that works as a bit of a strain relief. So I'm not too happy about that, but this board in general is a failure. SMD microcontroller, despite the fact that the same chip is available as through-hole. So if you screw it up, you have to desolder it, put another one in. Pain in the ass. All these pads for pin headers are either 2 mil or 2 millimeter or 50 mil grit. There's no standard 100 mil grit pinouts like this, so you can't use it with a breadboard and nothing else. And there's a pot in here you can use. You can actually read on the ADC, analog digital converter here. We've got 8 LEDs and we've got one push button, if I remember correctly. Yeah, it's not a reset button, this is actually a push button you can read with a microcontroller. And then there is test board area here. Now again, this is all SMD. Again, it isn't 100 mil grid with whatever connectors they have, and this is stupid. I mean, if you think about it, you start working on this, you'll solder something on, desolder it again. It's only a matter of time until the first pads detach, and you can throw the whole thing away, rather than having a separate board or just providing headers so you can just use breadboard. So not overly happy about it, but I've got 8 LEDs I can make blink. I've got a microcontroller, I've got a program header, and I've got a problem. Because I want to... first off, another problem. Here are power headers, right? And I've already moved this rubber pad so I can actually solder things in here. Still have to clean it up. If I can solder some header in here for the power. They actually had these pads over these pads. Stupid. It's not really thought through. Biggest problem, however, is the Picket 2 programmer and this board and this set are no longer available. There's a successor, Picket 3, which has been around for 5 or 6 years, and it's obviously, and from all I've seen and heard, and at least from seen on 2 episodes on Dave Jones' AVBlog, the Picket 3 is a huge step backward, to put it diplomatically. But you don't get this one anymore. I think you can still buy this test pad or this target board, but not the Picket 2. So if you want to play along with Picket, with the PIC microcontrollers, and the Picket 3, by the way, is no longer supported using the open source Linux interface. That's a big problem. You can try to get one of these secondhand on eBay, or you can try, there's still clones of these around. I don't know how good they are, because I do have this, but if you want to use PIC with open source tools, you have a bit of a problem there. If you want to use PIC with the regular Windows-based, what's it called, MPLAB IDE, you can use Picket 3. It's still a pretty crappy thing, but at least it's going to work. And when I say crappy, I mean one of those comments that Dave Jones made on his episode in the AVBlog. The Picket 3 doesn't even have enough flash memory inside, so it could store a firmware that works with all PIC targets. So depending on the target you use, you might have to first reflash the firmware in the Picket 3. not with the Picket 2, but with the Picket 3. So yeah, that's really, it's not good. But the Picket 2 is supposed to be a pretty decent device, and from what little I've tried so far, it actually works. So that's what I wanted to show you for today, and let me get the camera back to its normal place. Hang on. Okay, that's better. So these are the options I've come up with so far. There are obviously more. What are my plans? I'm going to use these things. I'll try to get rid of the, what is it? Of the PIC Debug Express as quickly as possible. It should be fairly straightforward to replace this with some breadboard or maybe perf board, similar setup at some point, but only once I got the toolchain up and running. Yeah, so said the MSP430 Launchpad, it's really a no-brainer. Just get one. And with the Atmore word, it's a bit more difficult. It really depends on your budget, so I'm not going to give you any blanket recommendation. I'm probably going to use all those three devices shown you, the cheap Diamex or whatever, yeah, Diamex, the cheapy programmer, no name sort of thing, the Bus Pirate, and the AVR Dragon. AVR Dragon for programming, for debugging, and the we'll see the Bus Pirate when we play around with SPI and I2C and that sort of stuff, I think. Okay, so much for today. Hope you enjoyed it. If you had questions, comments, whatever, come to the forum as usual at www.stepladder-it.com/bivblog/38 this time, and hopefully see you again soon. Next time we will get the programmers to work, and yes, we go for all three platforms in one video, I guess. It doesn't really take that long. I just wanted to make sure you see what we're dealing with and what you might actually want to buy for yourself. Okay, so much for today. See you again soon. Bye.